Hello and welcome to practice problems for Handout 16. Handout 16 and Homework 16 are all about optimum capital structure for all stakeholders, primarily for all stakeholders, using our weighted average cost of capital. So let's jump right into an example which is very similar to the Handout 16 homework and very similar to something you might see on the final. So Super Sales is a profitable company, stayed the same size for the past few years, and you expect it to stay in this steady state condition into perpetuity, except we might change its capital structure. For simple steady state firms like this, as we've already seen, the free cash flow to owners is equal to the net income. And so it tells us here, given the below data, that it wants us to find the requested information. So let's start scrolling through and seeing the given data. So we have an income statement. So since it's a steady state firm, that's going to be historical income statement and future income statement. And again, because it's a excuse me, very straightforward, simple firm, we've got the free cash flow to owners is equal to net income. And as of right now, the company is debt free, but we're probably going to want to change all that. So here are some constants. At this time in the big bad world, the risk-free rate, as measured by Treasuries, is about 3%. The equity market return rate we estimate to be 7%, and beta U, that stands for unleveraged. That means firm with no leverage, and that's exactly what we've got up here. No leverage, no interest payment on that debt, so that fits. So our unlevered beta is 1.15, and the tax rate for the firm is 40%. So what else do we have here? We've got a table set up where we're looking at 5 different cases of debt to debt plus equity here, right? Um, and so this would be the existing case where there is no debt. And then here's a hypothetical case where this ratio goes up to 20%, then 40%, then 60%, then 80%. So for each of these cases, we've got the pre-tax cost of debt capital, RD. And how did we get that again? We went out there and looked at comps for this company that have about 20% leverage, have about 40% leverage, 60% leverage, and 80% leverage. And we just look up from their financial statements what their pre-tax cost of debt is. For SSI in its current state, we get the 5.75 by going to their bank and saying, what if we took out a small loan, small enough loan that it wouldn't really materially change our leverage ratio? What would you charge us on that loan? And the bank says 5.75%. And that's how that number was come to. Okay. Now, as we've talked about before, in the same way that the cost of debt capital goes up with increasing leverage. Why? Because the probability of bankruptcy goes up with that increasing leverage. Same thing is true for the cost of equity capital, right? Because shareholders typically get nothing in a bankruptcy. So the more levered the firm is, the higher the cost of capital demanded by shareholders is. So what I've got here for cases 2 with 20% leverage, 3 with 40% leverage, I have an estimate of what the equity cost of capital would be, and I got that by using Hamada's equation, which again, you don't need to know, but I got my cost of equity capital using CAPM in all of these cases with beta. And the way it works with CAPM is the more leverage you have, the bigger the beta gets, and that translates directly into a bigger cost of equity capital, which is what we would expect. Okay, so I think we have enough here to start answering all the questions. So the questions are in green, the answers are in red, and what I want to do is show you how I got these answers in the type of way that you'd be able to get them on your calculator. Okay, so the first question, what is the equity cost of capital for case 1? So that's this question mark right there, and I'm here to tell you it's 7.6%. So this is a bit of a review question, right? And it goes like this. It says to use CAPM. So if we use CAPM, we'd say that RE is equal to RRF, whoops, RRF plus RM minus RRF times beta. Okay, and if I plug that all in, that's going to be, I think I have all that information. Again, it's a bit of review, but I have my RF, I have my RRM, I have my beta in the firm's unlevered state. So I can say 3% plus 7% minus 3% times beta unlevered 1.15. Okay, and let's take that and put it into our Excel calculator. Okay, and we get our 7.60%. Okay, so far so good. So again, that was just a little bit of warm-up review. What is the weighted average cost of capital for each case here, case 1 through 5? And again, I have the answers here for case 1. It's 7.6%. And that's equal to, by the way, the equity cost of capital. Why? Because there is no debt. Even though there is a debt cost of capital, if they took out a very small loan, there is no debt, so that doesn't impact anything. So if there's no debt, the weighted average cost of capital is the equity cost of capital. Okay, and then how did I get all of these others? I used our equation for weighted average cost of capital, and I just plugged in. So let's see if we can plug in, for example, our 20% leverage case number case number 2 there. So let's see what we can do here. Our WACC is equal to, I'm just going to plug in the numbers here. 1 minus, I believe the tax rate is 40%. I got to go up and look. Yep, it's 40%. 40%. Okay, times, what is the weight of the debt? Well, that is D over D plus E, so that's going to be 20%, and I need to multiply that, of course, by our pre-tax cost of debt capital, which is, whoops, 6.75%. I'll type that in, 0.75%, okay? So that's my debt term, and you see how the tax shield has the effect of lowering that from the pre-tax cost of debt. Okay, and let's see, for the equity, the weight of the equity is going to be 80%. If the weight of debt is 20, the weight of the equity is going to be 80%, and I need to multiply that by what the cost of equity capital would be if they were levered up to 20%. So that's 8.29%. 0.29%. Okay, and that, I believe, is it. So let's go ahead and put this into our calculator. Okay, and we get here our 7.44%, exactly what we have up here. Okay, so I'll leave it for you to go ahead and do case 3, etc., etc. I'll even make this a little nicer for you here. Let's make that 10, and then I can pull this over here, make it a little less confusing. So that's equal to, that's directly below what we've got there. Okay, good. So the weighted average cost of capital for each case, we've seen how to compute one, and I'll leave it to you to compute the rest. So what's the optimum weighted average cost of capital? So now I'm going to say you believe me that I got all these correct. Okay, the optimum weighted average cost of capital is always the smallest one. Okay, so that's going to be this one for case 2. Okay, so that's how I got my 7.44%, because it's the smallest one. And the smallest one is always best, because that's the one that's going to maximize the present value of the future free cash flows to everybody. All right, so That's good. And the corresponding debt to capitalization ratio is indeed 20%. All right, so that's all good, but let's go a little further. Let's do another problem while we have all this information here. SSI is for sale for the price shown, 100% of the firm's stock. You would like to buy the firm as part of their purchase transaction. You will optimize SSI's capital structure for all stakeholders. So that means the weighted average cost of capital exercise we did up above will apply. Okay, and as usual, if we're going to recapitalize a firm when we buy it, we're going to use some of our cash and we're going to have the firm take out a loan on the purchase date to fund the remaining amount. Okay, so the purchase price of the firm is 250 million. So if we want the optimum cost of capital ratio for everyone, that's going to be weighted average cost of capital of 20% as we saw before. So that's just as shown above. Okay, and how much of the cash would you use to purchase the firm? Okay, so that's going to be what? That's going to be 250 times 80%. Okay, and whoops, let's just do this. Okay, and we don't want percent here. Let's do this. There we go. So this is how I got the 200, right? If our debt leverage ratio is going to be 20%, we have to spend 80% of the total price out of our own money, and that's 200. And how do we fund the rest of the purchase? Well, it's either going to be 250 minus 200, or we could say 250 times 20%, which better give us the same answer of 50. So let's see if that's true. Okay, and I think that 5,000% is in fact equal to 50. And that's correct. So that's how we suss out how much we, as a private equity firm, would have to put in of our own money and how much we would get the firm to take out as a loan on the day of close, and then the proceeds of that loan would go with our proceeds to pay the prior owners of the firm the 250 million they demand to give up 100% of their shares. Okay, so that's it for practice problems for homework 16. I'll look forward to seeing you in practice problems for homework 17 coming up.